Hello everybody, how are you? Hope all of you are doing well. Today in this session, I am going to discuss about our project which is Arduino based stepper motor controller. So let's start our presentation. These are all the topics that we will discuss throughout the presentation. Now let us start one by one. First of all, we will know what are the objectives of our stepper motor controller project. Our stepper motor controller should be very easy to control. That means any person may or may not have any knowledge of stepper motor, of controller, he or she will be able to control any stepper motor by using our controller very easily. Now the second one is compatibility. By using our controller, you can control any kind of bipolar stepper motor along with the combination of any kind of bipolar stepper motor driver. That means our controller is compatible with all kinds of bipolar stepper motor models available in the market. Third one is the cost efficient. We have tried to reduce the cost as much as possible so that anybody can afford it. And the last one is all-in-one control. Means you can control almost every parameter of any bipolar stepper motor like speed, rotation direction, position hold, etc. You don't need to purchase a specific controller to control a specific parameter. It is an universal controller. Using this, you can control any parameter like speed, direction, etc. of any bipolar stepper motor. But before going into details of our project, I want to ask you a question. Why the stepper motor? Because you know the stepper motors are more expensive than a DC motor, and the DC motors are easily available in the market also. So in this DC motors era, why we will consider a stepper motor? What are the advantages of stepper motor rather than a DC motor? Now to answer these questions, I have compared the stepper motor along with the DC motor. Now the stepper motor has a few advantages over a DC motor, like precise control. That means the speed, direction, every parameter can be controlled very precisely. The second one is high torque. Now from a DC motor you can achieve high torque but not directly. By means of a gear mechanism it is only possible. Whereas in case of stepper motor, directly you can achieve the high torque compared to a same specified DC motor. The third one is constant speed. In case of heavy load also, the stepper motor maintains almost a constant speed, where in DC motor if the load is increased, the speed decreases rapidly. The fourth one is reliability. The longevity or the life of a stepper motor is much more. That is almost 10,000 hours of continuous use, which is much more than a DC motor. Now, the problem is, unlike a DC motor, we cannot connect a stepper motor directly to the supply. For that, we need a controller. So, why we need a stepper motor controller? Let us discuss about that. If you see a bipolar stepper motor, inside that there is two pair coil assembly, and each coil acts like an electromagnet. The rotor itself is a permanent magnet. Now, when the electromagnets are energized by means of pulses or the DC pulses of some particular width at some particular time, then the rotor starts to rotate. And the rotation, direction and position of the rotor is controlled by feeding pulses to the four input points, that means nothing but the coils. Now, giving input to these coils by means of pulses is not possible by maintaining a physically switches. For that, we can use switching devices like MOSFET is here. As you can see here, The switching that is being done over here, that are nothing but the switching devices. Now for controlling a single stepper motor, you can see almost 8 switching devices are required. Now the circuit will be much more messy and as well as the costing will increase. So rather than using switches, we use the stepper motor controller. Means to control a stepper motor we need pulses, and that pulses are fed from a stepper motor controller, and thus pulses cannot be generated physically by means of switches, that are only generated by switching devices or the stepper motor controller. To maintain the minimal cost, we generally use the stepper motor controller. So that is the main need of a stepper motor controller. Now in our controller, we are giving some features. Now the first feature is LCD display. Whatever parameters you are controlling of any bipolar stepper motor, you can directly see what is the position, what is the speed, etc. parameter in the LCD display that is integrated in our controller. The second one is ease of use. Any person may or may not have the proper knowledge of the controller or stepper motor can be able to use this controller very easily. Now the third one is the compatibility that we have already discussed. That is, our controller is compatible with any kind of stepper motor along with the any kind of stepper motor driver. Now the fourth one is the multiple modes. If I talk about the multiple modes, there I will tell you that our stepper motor controller has been divided into some portions that we will discuss the next slide. That means the main controller has been divided particularly in two portions. One is manual control and one is automatic control. In the automatic control portion, we will see that there are the multiple modes, and in each mode the motor will perform some specific action by means of given input. So if, as I am telling that our controller has been divided some portions, so it is very important to discuss what are the portions that is available on our controller. Now let us discuss this in means of the PCB. This is the PCB that we have used for designing our stepper motor controller. The median section of the PCB that is shown over here, that is the power section, where you will be able to see some ICs, some switches, etc. The left side is used to control the stepper motor manually and is named as the manual control. The right side is the automatic control. In case of the manual control, we will generally discuss about the three controlling parameters. One is speed, direction and the holding torque. Now a new concept that may come into our mind, what is holding torque? Holding torque is a mechanism that is only possible by means of a stepper motor. The stepper motor can hold a particular position which the DC motor cannot. So that is called the holding torque, and at that time when the stepper motor is holding particular position, you cannot move the shaft of a stepper motor unless or until the supply is not removed. Now for automatic control, well, I am keeping it surprise. I will reveal it later. Throughout this presentation, we will only discuss the manual control mechanism. But the problem is to make this project and to make this project successful, we have faced some problems, and as well as we have also get some solutions. Now the first problem was selection of the proper board. Now we know that we are making the Arduino based stepper motor controller, but there are 4 types of Arduino board available in the market. Now which board will be suitable for our controller? That is the problem. Now let us discuss one by one. The first Arduino board that is available in the market, which is called Arduino Mega. Now Arduino Mega is very much useful for our project. But the problem with the Arduino Mega is is very large and the size cannot be reduced. So that's why we rejected the Arduino Mega due to its big size. Arduino Nano and Arduino Pro Mini has some problem, that is, it cannot generate the high voltage pulses which is required for the driver to drive the stepper motor. So that's why, due to the low voltage pulses, Arduino Nano and Arduino Pro Mini are rejected. Though you can use the Arduino Nano and Arduino Pro Mini in our project, but if the load increases on the motor, then they will fail. Now the one and only remaining Arduino board, that is the Arduino Uno. Now you may ask me a question. Arduino Uno board is not so small that you can use in this project. So that's why, though Arduino Uno is right, but we will only use the Arduino Uno IC. That means only use the Atmega 328P microcontroller. We will not use the total Arduino Uno module. Well, now our Arduino board selection is done. Now the next problem is what motor to be selected and which driver is to be used. See, one side we are using Arduino Uno. Though I am showing the Arduino Uno module, but remember one thing, we will only use the Arduino Uno module IC or the microcontroller IC only, along with the driver circuitry, that is Atmega 328P. For understanding purpose, I am only using the Arduino Uno board. So one side we have Arduino Uno and another side we have the stepper motor. Now here I am using the NEMA 17 stepper motor, which is very popular and well-known stepper motor. Though there are different model of bipolar stepper motors are available in the market, you can use any of them. But here we are using the NEMA 17 motor. In case of NEMA 17 motor, unlike the DC motor, the motor ratings or the motor specification is not given by the RPM. You have seen that in case of DC motor, the specification of a motor is determined by its revolution per minute. But in case of stepper motor, the specification is given by the steps per revolution. In case of NEMA 17 stepper motor, you can see that is the specification has been given 200 steps per revolution. I am telling this point because this manual control portion is not only used to understand the manual controlling, or not only used to control the motor manually. This manual control portion has been made here just to understand the exact working of a stepper motor. Now 200 steps per revolution, this parameter is very important. Then that we will discuss later, that we will understand later when we will demonstrate it. Now Arduino alone is not sufficient to feed the pulses to a stepper motor. So to handshake between the Arduino as well as the stepper motor, we need a stepper motor driver. However, there are different drivers available to control different bipolar stepper motors. We are taking the cheapest driver, which is called A4988 driver. Now A4988 driver has a limitation, that is it can only supply the maximum current of 2 ampere. So that's our next problem. As we are taking the cheapest driver, A4988 driver, that has a limitation. The limitation is A4988 driver can only supply the maximum 1 ampere to 2 ampere current to a particular stepper motor. So you must have to select that stepper motor whose specified current rating is less than 2 ampere. If the specified current rating is greater than 2 ampere or the motor tries to draw more current than the specified value of the driver, then the driver will burn out. So that means which driver is to be selected and which motor is to be selected, that combination must be known to you. There must be a handshaking mechanism between them. That means that driver and the motor will be selected by matching their currents and voltage specifications. Now, the problem is in our circuitry, total circuit of the controller, we have used different components of different ratings, especially A4988 and the Arduino. Those two have different voltage ratings. In case of A4988, it works on the 12 volt power supply, and Atmega 328P IC works on the 5 volt power supply along with all the other components like rotary encoder, display, etc. uses the 5 volt power supply. Now you can see that there is a voltage mismatch. Now this mismatch can be easily solved into two ways. The first one is you can either use a buck converter whose input will be the 12 volt and output will be the 5 volt. Otherwise, you can also use a 7805 regulator IC. You can use any of them, but the buck converter is little more expensive than the regulator IC. That's why we are rejecting the buck converter right now, and we will use the 7805 IC. Now let us see what are the components that we are using in this project. These are all the components that we will use throughout this project. For communication channels, we will use these four components, as you can see. Now let us understand how our total controller works. Remember one thing, that here we will discuss only the manual control mechanism. In the next session, I will discuss about the automatic control mechanism. See, we have the Arduino Uno, means we have the microcontroller IC. I am showing here the Arduino Uno right now, but we will use the microcontroller IC. Now, when a power supply cord is inserted the Arduino Uno will on. As soon as the Arduino board turns on, it will supply some signals to both the display as well as the driver. And as soon as getting the supply, the display will be turned on and it will be available in the running mode. You can see that the by default speed and position has been shown over the display. By default speed is 50 and the position is 0. Now after getting the supply, the A4988 driver will start supplying pulses to the NEMA 17 stepper motor. And the NEMA 17 stepper motor is connected directly with the A4988 driver. Here you can see one thing, that is the position is nothing but the shaft position, or you can also understand it like this, that is the steps that will be counted here, that is nothing but the position here. The initial starting position of the shaft has been taken 0 over here. Okay. Now there are also two buttons which are called the CW and CCW, that means the clockwise and anti-clockwise movement of the motor. These two buttons are used for rotating the motor in the clockwise and the anti-clockwise direction. The rotary encoder has been used here to control the speed of the stepper motor. The rotary encoder will feed the signal to the Arduino Uno, and according to that, Arduino Uno will perform the action and give the instruction by step and direction control signals to the A4988 drivers, and the speed of the motor will be increased and decreased, and the speed will be directly monitored by means of the display over here. Now we have done the simulation on the Wowkey software, so let us see the simulation. See, as soon as turning on the power supply over here, the speed, that is the 50, and the position, that is the 0, is shown over here. The speed is controlled by the rotary encoder, and the position 0 is controlled by these two push button switches. Means the two push button switches are used to control the position or the shaft position in the clockwise direction as well as the anti-clockwise direction. The position is nothing but the steps of the stepper motor. Now if we increase or we we are decreasing the speed of the stepper motor first, and after pressing the anti-clockwise rotation button, you can see that is the position is getting negative, mean the motor is rotating in the anti-clockwise direction. Now here I have told you one thing, that remember the rating, that is the 200 steps per revolution. As you can see, the shaft completed one complete rotation either in the clockwise direction or in the anti-clockwise direction, means it is completing its 200 steps. You can see that 201 steps, that is almost 200 steps we can consider. It has been rotated by 201 steps, and due to the 201 steps of rotation, it has completed its one complete revolution in the anti-clockwise direction. Similarly, if we click on the clockwise direction clockwise direction button, you can see that is the motor shaft is rotating in the clockwise direction. And again, after rotating the 200 steps, after covering the 200 steps, the motor shaft has been rotated the 360 degree, or it has completed the one complete revolution here. Now we will increase the speed of the stepper motor. You can see the shaft rotation is being done, but definitely at higher speed. And that was all about our demonstration. This is the physical diagram, or this is the actual project that we have made. This is the work plan from starting or the first week of the July till the last week of the November. The complete working steps has been shown over here, and this is the costing of our component along with the component list, that whatever we have used throughout this project, considering both manual and automatic controller. Now let us see what are the softwares we have used to build this project. The first and the very well-known software that we have used here is Arduino IDE. Now Arduino IDE is used here to basically code the Atmega 328P IC, and as well as to upload the code inside the IC. The Proteus 8 software has been used here to draw the schematic and little bit of simulation. Now the third software that we have used, that is the most important, which is EasyEDA, which is also used to design the PCB as well as the schematic or the connection diagram that we have used to make the PCB. And using this, using EasyEDA software, we have generated the Gerber file, and according to the Gerber file, we ordered our custom design PCB. And the fourth, and that is also very important software, which I have already shown you, depending upon which we have simulated the things, which is Wowkey software. Now this Wowkey software is specially designed for Arduino ESP32, STM32 and many other popular boards. It is a universal software. The programming languages that we have used, that is only the C++ language, which is used to code the Arduino in the Arduino IDE software. But in spite of having such disadvantages, we have also have some cons. Means our Arduino stepper controller have some pros and cons. Let us discuss those one by one. Now first we will discuss what are the positive sides and what are the pros of our controller. Definitely the pros of our controller, considering those are LCD display, compatibility and all-in-one, that I have already discussed you. That is, LCD display is used for navigations. Compatibility means any kind of stepper motor is compatible with this controller along with a particular or specific driver, and all-in-one means you can control any parameter of any bipolar stepper motor. You don't need to use the separate stepper motor controller to control a particular parameter of a stepper motor. Now coming to the cons, there are several cons and that can also be removed. Those are fragile. Number one, fragile means you can see that is our body is made by the transparent and the white acrylic sheet. But the problem with the acrylic sheet is this 3 mm acrylic sheet is very much fragile. That is, very easily the scratches and the fractures can be made on this acrylic sheet. The second one is the noising. The noise is the biggest drawback of our stepper motor controller, and that is the cause of this noise is a 4988 stepper motor driver that we have used here. Now, due to this A4988 stepper motor drivers, the motor produces some hiss noise, and which that can also be removed just by changing the driver. Due to the lower cost, we have used it to make this prototype. But in case of industrial use, it is recommended not to use this driver. It is the basic one. Use some advanced version of the A4988. That is, one is DRV8825. That is another more important or very well-known driver which is used to remove the hiss noise of a stepper motor. The overheating is the problem of the A4988 stepper motor driver. That is, in long run, this motor driver overheats. I have already lost 2 of these drivers, and this is the third one driver that we are using it. The IC of the A4988 driver easily overheats in the long run, and in high load, it genuinely overheats that it can burn also. Now let us see where we can use our controller. What is the utilities of our controller? Now the first utilities of our controller is, by using a stepper motor controller and the stepper motor, you can run the home appliances like refrigerator, printers, copy machines, etc. The home appliance inside the home appliances, the stepper motors are used by means of the stepper motor controller. Definitely, those stepper motor controller is specifically designed. Here we have designed the universal stepper motor controller. In the home appliances, the stepper motor controller is designed specifically for doing a particular task or to maintain or to control a particular parameter of a stepper motor. The second one is in commercial cases, that is vending machines, ATMs, we also use these stepper motor controllers. And in case of industries like XY, positioning tables, and very well known conveyor belts and robotic drives, we also use the stepper motor controller. And the fourth one is the Arduino based stepper motor controller is specifically used in case of the 3D printing equipments. In 3D printer, all of the 3D printers use this same stepper motor, that is the NEMA 17 stepper motor, along with a specific stepper motor controller, which is also designed by the Arduino. And in medical imaging machines, MRI machines, robotics, and CNC milling machines also, we can use the stepper motor controller. Now, the question arises is, can we upgrade it, or does it have some future enhancement that we can add on some more features with the stepper motor controller? Yes, we have. We have found that there are the 3 major upgrades or 3 major future enhancements that can be made in this stepper motor controller. The first one is that will be made soon, which is the automatic stepper motor controller. Here you can see that to control a particular parameter like clockwise or anti-clockwise rotation or the speed of the stepper motor, always you have to be in touch with the stepper motor controller. But can we do something like this, so we can set some particular parameters or some particular particular direction or the particular position, etc., depending upon which our stepper motor will act? Yes, it is possible. And along with this, some more modes, in some 3 or 4 modes we can operate the stepper motor, that will be also done in the automatic stepper motor controller. And this is the one and only, this is the main important future enhancement that can be done upon this. And the second one is, yes, we can use the noise, that is the low noise is possible just by changing the stepper motor driver. Okay. And the third one is the wireless control. Now the wireless control means by using a particular application or the website, we can control almost each and every parameter of the stepper motor. But right now this cannot be done because to use this wireless control facility, we must have to use the IoT devices that are like ESP32 or ESP8266 boards. Okay, so by using this, the wireless control will be easy. As we are limited to the Arduino, so we cannot use the wireless control, include this wireless control facility right now. But this can be a future enhancement. For the conclusion then, whatever we have seen over this project or throughout this presentation, the first one is we have learned the hardware integration. Definitely each and every components we have for that we have designed the PCB, and upon PCB we have integrated each and every components along with some ICs, capacitors, LEDs, etc. So we have done the hardware integration and our hardware knowledge has become some good. And the second one is the problem solving. Yes, definitely we have faced many problems, as well as we have also found some solutions for those problems. So our problem solving skill has been increased a little bit. Programming skills here, though we have used only C++ programming, so I can say that is the during programming I have made some mistakes also. So our programming skills has also been increased. Now the fourth one is the flexibility. Flexibility means, as I have already told, that is our stepper motor controller is not bounded to NIMA 17 stepper motor. It is also bounded. It is also it can also be attached with some other bipolar stepper motor along with the any available bipolar stepper motor driver. Okay, so that's why this controller with this controller, without changing the circuit configuration, you can control any parameter of any bipolar stepper motor available in the market. So that is our controller is much more flexible. These are all the references that we have used throughout the presentation, and depending upon which we have made some study, and all the links has been provided over here. So that's all for today. Thank you for your patience. If you want to give some feedback, the feedback form has been provided here. You can give your valuable feedback by means of the feedback form. If you have any questions, you can directly ask me. Otherwise, you can directly connect me with my contact number and with my email address. So that's all for today. Thank you. Have a nice day.